Now if x1 and x2 are real and distinct roots of ax square plus bx plus c equal to 0, then the value of limit extends to x1 1 plus sine of ax square plus bx plus c whole raised to the power 1 by x minus x1. So we need, what is the data given? That x1 and x2 are the roots of quadratic equation ax square plus bx plus c equal to 0. Now when do we say these are the roots of ax square plus bx plus c equal to 0? As x1 and x2 are the roots of ax square plus bx plus c equal to 0, then can we write the expression ax square plus bx plus c can be factorized as a times x minus x1 into x minus x2, right? Now we'll use this property to evaluate the required limit. What is the required limit? Limit extends to x1 1 plus sine of ax square plus bx plus c whole raised to the power 1 by x minus x1. If you look at the base as extends to x1, the value of ax square plus bx plus c would tend to 0, right? As ax square plus bx plus c tends to 0 because x is satisfied by x1, as x1 is the root of the quadratic equation given. As ax square plus bx plus c tends to 0, shall we mention sine of ax square plus bx plus c would also tend to 0, right? Then how is the base of this expression given? 1 plus 0, right? So shall we say this expression is in the form 1 to the power of infinity form, right? As the power is 1 by x1 minus x1, that is 1 by 0. So the power is tending to infinity and the base is tending to 1 at the given limit. Then the limit is in the form 1 to the power of infinity. As the limit is tending in the form 1 to the power of infinity, which formula would help us to find the limits? Yes, by Euler's form. This given limit would be e to the power of limit extends to x1 sine of ax square plus bx plus c times 1 by x minus x1, right? Now it would be appropriate if we can revise what is the most important form of Euler's formula. What does Euler's formula says? If limit extends to a, f of x whole raised to the power g of x is the required limit, where is some value L, then if limit extends to a, f of x is tending to 1 and limit extends to a, g of x is tending to infinite, then if the limit is in the form 1 to the power of infinity, that's what is a form in the given question, then the value of L will also be equal to limit e to the power of limit extends to a. At the same limit, this limit will now become f of x minus 1 into 1 by g of x into g of x, right? This value, this limit, the calculation of the limit by this formula when the given limit L is in the form 1 to the power of infinity can be evaluated as e to the power of limit extends to a, f of x minus 1 into g of x. A very, very important application in limits. Now that's what is the limit we are using here, right? Then this limit would be now e to the power of limit extends to x1, as we have ax square plus bx plus c factorized as a times x minus x1 into x minus x2 by x minus x1. Now let us multiply this numerator and denominator with a times x minus x2 and multiply with a times x minus x2. Now if you look at the first part of the limit, this is as x tends to x1, x minus x1 tends to 0. As x minus x1 tends to 0, the entire denominator a times x minus x1 into x minus x2 tends to 0. Then this is already in the standard form, right? Then it is limit 1 into, as x tends to x1, x1 is in the domain of this function, so directly substitutable, a into x1 minus x2. So how much is this limit? E to the power of a times x1 minus x2 will be the limit. A problem which is using two important applications of limits. One is an important Euler's formula and the other one is sin h by h, as h tends to 0 would be always 1, right? So which option is it satisfying? Yes, the option presented C, which says the value of the required limit is e to the power of a into x1 minus x2.